Okay, so for this problem, go ahead and take a moment. See if you can't graph f of theta equals -3 secant of theta minus pi plus 1. Try to approach it like the last example we had. Okay, so from here, remember to graph secant, we're basically graphing cosine. Remember, secant is the reciprocal of cosine, so if we graph cosine, then we can just apply the reciprocal from there and get our graph. So, to graph cosine of theta minus pi, we would take theta minus pi, and we would set that less than or equal to 2 pi, but also greater than or equal to 0, and solve for theta. We would start by adding pi to each side, to all three, that is. And then we end up with pi is less than or equal to theta, which is less than or equal to 3 pi. So this represents one period for our graph. Now we're actually going to find the period, which remember is 2 pi over b. And b in this case is the number multiplied to theta, but since there isn't a number multiplied to theta, that means b is just 1. So the period is 2 pi, a standard period for sine or cosine. So remember, we always take p and divide it by 4, which gives us 2 pi over 4. And when we reduce that, we get pi over 2. We can divide 2 from the top and bottom, leaving us with pi over 2. So remember, we always take this p over 4 value, and we set up our table, starting with the initial value of our inequality, which is pi, and we add pi over 2 to that 4 times. So pi plus pi over 2 is 3 pi over 2, plus pi over 2 again is 4 pi over 2, or 2 pi, plus pi over 2 again is 5 pi over 2, plus pi over 2 again is 6 pi over 2, which is 3 pi. And remember, we always do a quick check. Do our first and last values match the values of our inequality? If they do, then we've probably done this correctly. So, since we're dealing with cosine, remember our values always start with 1, go to 0, down to -1, back up to 0, and then up to 1. This is always true for cosine. So we'll start with our graph. We have our value at pi, and then 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. You can always put this little squiggly here to show that you've made a jump to the first tick mark on your graph. And now we are going to plot the point pi comma 1, 3 pi over 2 comma 0, 2 pi comma -1, 5 pi over 2 comma 0, and finally 3 pi comma 1, which gives us this almost cursive U shape. And this is our graph of cosine. Now remember, this isn't taking into account any of our vertical transformations, so we need to make a list of those. You could have also done this right before you made the graph. Either way is perfectly fine. So we start by checking if we're multiplying by a negative. We are. This negative means that we have a vertical reflection. From here, we check if we're multiplying by a number between 0 and 1 or greater than 1. Because we're multiplying by a number that's 3, a number that's greater than 1, that means we have a vertical stretch. If it were a 1/3, for example, instead of a 3, then that would mean we would have a vertical shrink. And then finally from here we have a +1. That means the entire graph gets shifted up 1. Okay, so let's go ahead and start with red, and we are going to start finding the graph of secant from here, and then we can apply our vertical transformations. So remember, wherever there's a 0, that means we have a vertical asymptote. From there, wherever we have a hill, that means we have an upward-facing parabola shape. So this is going to be half of a parabola because we don't have the full hill. It would look like this. So we would end up with a parabola that looks like this. But remember, we don't have this half of it. So we're going to go back to this half of the hill and create our half parabola. We have the same point here, and then we climb upward because we're taking the reciprocal of the hill. Over here we have a full valley, so we have a full downward facing parabola. And finally up here we have half of a hill, which means again we have half of an upward facing parabola. Remember, it's just a shape, it's not an actual parabola. So this half is going to be on the left side because we only have the left side of the hill, so it'll look like this. And now we can apply our vertical transformations. So we'll start with a vertical reflection in green. That means everything above the x-axis will get flipped down and everything below will get flipped up. So this half parabola shape will become a downward facing one. This downward one will flip up. And this upward half will flip down. So right now our graph is just what we see in green. Now we'll go ahead and switch to blue. We're going to apply a vertical stretch to the green graph where we just left off. So remember, everything gets stretched out long ways. So this point will stay the same, but for instance, this point, say if it's at y equals 2, well, -2, it's going to get multiplied by the 3 out here. So it's going to become, instead of -2, it'll be -6. So what happens? This gets stretched out vertically, like so. And the same thing will happen with the green parabola. But I do want to make one correction here before we keep going with this. And that is that this point here will not remain the same. That only happens if it's on the x-axis. So that's something to be aware of, and it's actually worth leaving that quick mistake in the video because it's so easy to forget this. It's only when we're on the x-axis that that point stays the same when we apply a vertical stretch. But here, because we're at -1, when we multiply by that 3, it's going to be at -3. This point will move down to. And then the parabola shape will continue from there. Likewise, the same thing is going to happen here. Instead of a 1, it's going to start at 3. And then we create the parabola shape. And likewise, here, instead of at -1, it'll also be at -3, and we create the shape. I don't generally like to leave a mistake like that in a video. I would like to redo it, but this is something that's so common, it is absolutely worth leaving so that you can see you have to be aware of this. Don't get caught up with that. Make sure you always remember that you multiply all of your y values by that 3 or whatever numbers out front. So this would become a -3 as the starting part. Okay, and now finally from here we can apply the last transformation. We shift everything up 1. So starting at this point of -3, it now starts at -2 and shifts down. Starting at this +3, it starts at 4 now, because again we're shifting up 1, like so. And finally, starting at -3, we go up to -2, and it shifts down as well. Obviously, this gets quite messy, but this is why it's very useful to use some sort of coloring system so that we can finally put f of theta is the brown graph. We can see that this is the only thing we should be looking at when we're actually observing the final graph. F of theta is just this parabola shape here, the vertical asymptotes, and then these two half parabola shapes here. And this is the graph of -3 secant times theta minus pi plus 1.